Hydraulic and pneumatic linear actuators, or cylinders, are found where linear motion is needed for lifting, crushing, pushing, or clamping. Continuous rotary actuators come in handy for winding, drilling, and vehicle drivetrains. Each type of actuator has advantages and disadvantages. Hydraulic actuators are strong and positionable, require non-compressible fluid, and are relatively slow-moving, whereas pneumatic actuators are fast and require fewer components to operate. They are not typically positionable. Single-acting pneumatic systems require only the actuator, a constant supply of pressurized air, and a control valve. When the valve opens, air passes to the actuator, and pressure begins to build until the pressure in the actuator equals the pressure in the tank, or the valve is closed. Depending on the load, the actuator will move quickly, without full force, until the pressure builds. When the valve is open to the atmosphere, the actuator returns either by a return spring or by the load. In double-acting systems, an additional valve circuit is connected to the opposite side of the actuator. As before, the side of the actuator not under pressure expels its volume to the atmosphere. In either system, the actuator can move due to the changes in load, even if the valves are closed, because air within the actuator is compressible. It behaves like a shock absorber. Simple hydraulic systems use a high-pressure pump that draws fluid from a non-pressurized hydraulic fluid reservoir. A double-acting valve directs the fluid to the actuator. To prevent overpressure, a relief valve between the pump and valve bypasses fluid until needed. The entire system is flooded with hydraulic fluid. When the valve changes position, the actuator moves proportionally to the volume of fluid pumped. The pressure required for motion is equal to the applied load. In return mode, the expelled fluid returns to the reservoir to be used again. In the valve center position, the actuator cannot move due to changes in load because the fluid is not compressible or expandable. This is how hydraulic actuators are infinitely positionable. The power of linear actuators is based on the surface area of the piston and the pressure of the pump. A 1 psi pump will put 1 pound of pressure on each square inch of the piston area. It must be taken into account that the return force is always reduced due to the rod, which reduces the overall surface area on that side of the piston. Speed is relative to pump capacity and the actuator's cylindrical volume. A 1 GPM pump will push 231 cubic inches of fluid into the actuator in 1 minute. Continuous rotary actuators have the same surface area when spinning in either direction. Their power is dictated by the surface area of the vane and the diameter of the vane disc. The speed, or RPM, of a continuous rotary is determined by the pump GPM and the actuator total displaced volume. Divide the pump volume by the actuator to determine the number of revolutions per minute. Some rotary actuators use linear pistons to create limited rotation actuators that are useful for steering or swinging heavy loads. Hydraulic and pneumatic systems are improved using accessories such as filters for the removal of contaminants, dampers to absorb shock, gauges for pressure monitoring, accumulators for pressure compensation, and much more. Find a wide array of actuators, valves, and accessories for light or heavy-duty hydraulic and pneumatic systems on Digi-Key.com.
Want to watch more videos like this? Like and subscribe.